Okay, this is going to be mathematical vector addition. These are going to be perpendicular vectors. So this is vector addition. Vector addition. And so we're going to use some mathematical vectors. Really what you're going to need to know is the Pythagorean theorem and the definition of tangent. So what I've got is a vector that is going to be, it's going to be 8 centimeters. So let me draw this. 8 centimeters. That direction. So that's going to be 8. I'm going to call this a force vector, so it's going to be an 8 Newton force vector, so that's 8 centimeters long. And what I've got over here is a point. Here's my a point that I'm applying an 8 Newton force to, and then I'll apply a force of, let's say 3 newtons. And let's see if I can change the color of this guy here. Oh, I'm going to go pink. Options. This is so difficult. Pen settings, and I'll go color as being blue. Kind of probably should have done that to begin with, but anyway. So now I've got a blue. This will be the vertical. Hopefully it's blue. And that's going to be 3 newtons this way. So you got 3 newtons. So if you look at this, if you look at that, if those two forces are pulling that in their directions, you can see that this is probably going to end up moving somewhere along in this direction. All right, so that's fine. So we want to go ahead and figure out what that's going to be. So let me get rid of that. And so this is tail to tail. We've got a tail here and a tail there. We want to draw this head to tail. So I'm going to move this. I'm going to move him out to the head of the first vector that I drew. And that's going to be 3 centimeters. So I'll draw this 3 centimeters. Just like that. And draw my arrowhead. So this is 3 newtons. Down that direction. So our resultant then, the resultant is going to go, let's go to options, give me my pen settings, color I want that. I'm going to make this dark green. I'm going to make it pretty thick here, marker size. So we'll do there and we'll go there. So this is the resultant right there. Okay, that's the resultant. And that's what it is. So let me come back to my pen and find point red just to begin. So for graphically, I'll measure this, and I've got you can't see this, but I've got a little metric ruler here, of which all you should have had. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, about 8.9. I'll call that about 8.9. So the resultant is going to be 8.9 newtons, and I need to measure my angle. So I need to measure this angle right there, because I want that angle to be from the x-axis. Just makes things much easier. So I'll put my protractor on here, and I measure that to be a little over 20. So I'll say 20 degrees. So that's going to be at 20 degrees. And since I have it drawn this particular way, that's going to be 20 degrees south of east. So that's graphically. That's done graphically. Let's do this mathematically now. So mathematically, you can see that this is a right triangle, and I can use the Pythagorean theorem. So I can Pythagorize this thing. And of course we know the Pythagorean theorem is a squared plus b squared, and that's equal to c squared, where c is the hypotenuse. And so I'm going to call c, I'm going to call that the resultant. and that's equal to the square root of a squared plus b squared, and the resultant then is equal to the square root of 8 newtons squared plus 3 newtons squared. And let me walk over here, get my calculator so I can calculate, because you know I don't do calculations very much. Of course, you guys know that. Whereas, you know, you should always have a calculator handy, which I always do, of course, just in case. So 8 squared plus 3 squared is 73. Take the square root of 73 and we end up with 8.5. So I said 8.9 in my drawing. That's not bad. So the resultant then is going to be 8.5 newtons. All right? So that's the magnitude, but we need the direction. So the direction, here's our angle. Right here, here's our angle. We have a y component of 3, and we have an x component of 8. So if this is the angle, by definition, the tangent of the angle is equal to the opposite side over the adjacent. So tangent, I'll write that down, tangent of the angle theta is equal to the opposite divided by the adjacent. And to find the angle, I'm going to take the inverse tangent of that, opposite over adjacent. And so theta is equal to the inverse tangent of the y divided by x. And that's going to be something that we're going to want to stay with throughout all of these types of problems. So the inverse tangent of 3 divided by 11, 3 newtons divided by 11 newtons. Remember, we don't want negative numbers. And so the angle is going to be the inverse tangent of 3 divided by 11, and that gives us 15 point, say 15.2, so 15 degrees. Okay, so I was off a little bit on my angle. That's okay. I'm on a computer here, hello, with a big thick line. So, and that's going to be south of east. So we would report this mathematically as the resultant as being 8.5 newtons at 15 degrees south of east. Okay, so here is our graphic method. Here's graphically, and then this is mathematically. And we're done. That was easy. This is just easy stuff, and you can get this. All you got to do is do it. Now, how do I shut this thing off here?